Hello, everybody. I'm going to repeat the lecture that I gave in the class last Monday because I didn't put the switch on for recording. So we don't have a record of the class and the presentation. So what I'm going to be doing now is to just on my own go through that lecture again and talk about what we did at that Zoom class that we had on Monday. As you know, the subject again is on the theme of post-pandemic world, and the aspect of that theme that I want to cover today is a project called Starlink. It's a global internet project by Elon Musk. It's a project that hopes to deliver affordable internet to every part of the world, even the most remote parts. And he's developing a technology that will enable that to be delivered. At the moment, internet is really the privilege of developed urban areas and richer countries. Poor countries have less of an infrastructure to deliver internet. So if the affordability aspects are taken care of by a satellite type of internet system, then you don't need to lay the cables or dig up the roads and put thousands of miles of fiber optics or even copper. So it is going to be a very expensive thing to do if we adopt the current sort of technology to extend it to every part of the world. So this new technology that Elon Musk is developing is based on a number of satellites being positioned in orbit around the globe, which will then sort of cause the signals to go from one part of the world to another via these satellites. I'll be going into a little bit more detail when I show you the presentation that I have, but essentially what I want to do is to sort of give you an overview. So what we have is a project that is very essential for the future development of the world. And it needs to be done in a way that satisfies the poorer countries who can afford to be able to receive the signals through satellite antennas and to be able to then hook on to the global internet. And the cost also could be affordable in terms of what we pay as we regularly do monthly charges to our ISPs. Now, how can that also be reduced with this new technology? The way we can, or at least Starlink envisages, is to be able to have the setup of satellites circling the Earth in large numbers. These satellites would have to be positioned by launching of rockets. Now, traditionally, rockets have been very expensive to put any payload in orbit. But Elon Musk has developed a type of technology in his company called SpaceX. And that technology reuses the rocket. Once it's used, the boosters come back and sit back on the base. And it's the payload then sort of, goes into orbit. So that cuts down the cost enormously of putting these satellites up, especially in these big numbers. The numbers that he envisages is something of the order of 12,000 satellites. Already we have something of the order of about 600 or 800 of them already circling the Earth. And they have been tested out in some ways to say that everything works. Um, Sooner or later, to achieve this 12,000 satellites, one needs to, in fact, do many launches. And his new space rockets that he's developing can carry up to 400 at a time of them at each launch. So that reduces the cost further. Now you may ask, who's this Elon Musk? Well, Elon Musk is one of those visionaries which I think is an astounding character. He's a South African born, but became a Canadian and then came over to USA. And he was a real prodigy, very sort of smart in technology. He developed the Zip2 compression application to condense files, which he sold for a few $1 million. And he invested that money into PayPal, developing PayPal, which we have heard of. And that he then sold it to eBay for a fairly big sum. And with that money that he got from his sales, he wanted to satisfy his main vision, which is to develop a space program. But in between, he had to also sort of stop over and say, well, in order for me to make it a commercial proposition, he went into electric cars. So we have Tesla, you might be familiar with that. And then, of course, that is also coming in fairly fast as a project, which I shall be talking about in our future lectures. So here is a guy who has vision, one of plan B for Earth, so that the Earthlings, us that is, can go to Mars if there is a sort of a global disaster. But whether it's a disaster or not, it's a good sort of project. Now, why is he doing it and why is not NASA doing it? Well, NASA, is a government-funded entity. And you saw that NASA's sort of fortunes vary depending on which government funds their projects. We've got the Democrats, when they come in, they sort of do some funding, Republicans withhold, and then they put some money back in. So it's up and down game for them. So they decided, NASA, that they needed to bring in the commercial sort of world to help them out. And that's where Elon comes in. So he started to offer them certain types of technology, which they then gave him contracts for, delivering the payload to the International Space Station. So that's how he's developing his rockets. Let's hope all this sort of goes well. And I think so far he's done a brilliant job. And I have great faith in all the projects that he's undertaking. Okay, let me now sort of start you by going into a bit more detail by showing the presentation that I have for you to look at, and I'll record that now. So here we have, there we are. Okay, so what we are looking at is really a world past this pandemic. And in many ways, the past sort of projects are going to be affected by it, and Starlink is going to be affected in the sense that it's going to come in a lot faster. So let's see now. Here we are. Now, the launch of these rockets puts at the moment 60 satellites into orbit, and that has started only the last year or so, and we've got about 600 to 800 satellites already up circling the Earth. The value of these rockets, the rockets are called Falcon 9s, They're reusable rockets, and I think it's very important to emphasize that. Otherwise, the cost of these launches would have been enormous, and that would have not enabled Starlink to deliver affordable type of internet for the future. Now, this is the type of graphic that you can imagine where the satellites are going to be circling the Earth. And each of them is intelligent enough to communicate with the other. So when they pass over a certain land area, they will be then transferring the data in a very streamlined fashion to other satellites so that there is no break in communication with Earth or any of the projects that you might be sort of using that internet for. So here is Elon Musk saying that we are in dire needs. So he's saying a very significant unmet demand for low-cost global broadband capabilities is a must for the world. Now, if you just look at what we are doing with lockdown, we are dependent to a large extent on internet to communicate with each other, to do our work, to entertain ourselves, to listen to music, whatever it may be. So you can see how much of a utility internet has become. So it's not just a luxury, it's a sort of a necessity now. Now, this is the FCC. They are the Federal Communication people who authorize or give okay. So this is the okay for 7,500 satellites, and another 4,000 have already been given. Now, lately we have seen, this is on the 24th of April last year, one launch resulted in these number of satellites, 60 of them, traversing the sky until they get into a position, because they have their own little motors, which enables them to be keeping to the track that they have been assigned. So it's a very intelligent type of satellite as well that we are talking about. So here it is, there are two. Now, the question was, how can they avoid collisions and so on? Answer is that they have sensors in them. So when any satellite is coming near them, they're able to sort of position themselves in such a way there is no collision. So they're able to dodge collisions. And one of the things about this satellite is that has to sort of look at it not in just one direction, but in a number of directions, because the satellite's going that way as well, as opposed to, so it's like a network that they have to be aware of. Now, once they're in position, what happens is that if you're at one end of the world and you want to send a signal to the other end of the world, the satellite relay station on ground will beam up the signal to the satellite, and the satellite then sends it to its brother satellites, as it were, sister satellites, till it gets there. Now, you might think that there's a lot of links in the chain, and therefore it's a slow sort of path that will result. Not so. In fact, very briefly, I can say that the speed of this connectivity is faster than the fiberglass connectivity that we have terrestrially. So it's very, very fast. And I'll give you a bit details later. Here it is right now. You see, the signal that is sent between the satellites works on the speed of light. So in vacuum, the speed of light is something like 300,000 kilometers per second. But in glass, which is fiber optic glass and so on, sometimes these cables come to us, and that's about just a little over half that speed. So you can see the signal going in fiber optic sort of fiber cable is a lot slower than the satellite signals that is exchanged between themselves. So you can see there's going to be a big gain in speed. So here we are. It provides now another aspect is something called latency. Now, what is latency? Now, if you look at sometimes on TV, the announcer is asking a question to somebody on the other side of the world, and then there is a delay there because you can see that the guy hasn't sort of received the signal and he doesn't understand what the question is, and then then his face lights up and then he sort of responds. So there is that delay. That's called latency because the signal takes a good fair of time to go right up to the geocentric satellite that we've got at the moment, and then to come back again, and that takes time. So that is the delay. And of course, this Starlink project is a project that overcomes that difficulty because these are low Earth orbit that they're on. Their orbits are, I'll show you a little bit later on, they're much, much lower than the 22,000 or 33,000 kilometers high up at the geocentric satellite that we are using at the moment for TV programs and so on. This is essentially saying that the speed on the fiber optic is 1.5 times slower than the speed of light in vacuum. So if there is going to be a communication between London and New York, say, distance of 12,000 kilometers, then they have laid cables here from London to New York in order to make sure that the speed at which transactions can be done, especially the quotations for stock markets and so on, can be done very, very quickly and nobody has a delay advantage. Because, if there is a delay, people get to know about it a bit faster one way or another, and then they buy up, and then the systems become aware of it. So there is a bit of a handicap if there is going to be a delay. So we need to look at that. So this is the geocentric satellite, very high up on Earth, 36,000 kilometers high. And the latency is 2,400, sorry, I think I jumped that like that, 240 milliseconds. So that's quite slow in terms of the speeds that we're talking about. Compared to the 240 milliseconds, we have now a low orbit, which is a Starlink satellite, which is at the altitude of 1,000 kilometers. So the latency there is only about 8 milliseconds. So you can see it's practically instantaneous signal transfer taking place over there. 8 milliseconds is a very, very small number compared to 240. Now these low sort of Earth orbits, LEO satellites as they're called, they don't have the same sort of height, all of them. So they vary, which I think is also good for the safety of these satellites whizzing around the Earth. That's the same one that we saw earlier on. Okay, this is the type of network we are going to be seeing once the 12,000 satellites are up in the air, up globally. So in the first phase, they're going to be putting about 1,584 satellites in about 24 orbital planes. So with 66 satellites at each launch. 60 satellites at each launch. Now, we saw the New York to London. Now, this is the speed at which optical fiber works. That's 55 milliseconds for the signal to reach. Whereas Starlink, going through space, through the satellites, could be 20% faster, 43 milliseconds. And that is the other sort of cables. Now, there are already undersea cables that have been put in. One is called the Atlantic Crossing Cable and the Hibernia Express Cable. They have been laid at $300 million, I think it cost them to lay these cables. So quite an expensive proposition to lay cables under the seabed. So once the network is in position, they are going to be able to reach places like this, which is a remote sort of village in Africa, and you see there's no sort of um, pylons of any sort to transfer signals and all that. All they need is a dish, like our sky dishes that we have to catch the TV programs, a bit like that, a bit more intelligent, and that'll be at the cost of $200. Now, just imagine that a good few houses can be serviced by a $200 dish in even the remotest part of Asia and Africa, which is going to be a fantastic sort of boon for many, many third world citizens. Because once they get connected to the internet, then we are talking about really being able to have the commercial sort of interests, awareness come about, education come about, all sorts of facilities to communicate with each other, which is sorely lacking at the moment. Okay, I'm going to stop the sharing at the moment. And at the moment, because there is no class, and I've taken I seem to remember the questions that we had. One was about regulation. If Starlink becomes such a big project and becomes global, then what is the protection that you can have that it doesn't become a monopoly or abuses its position? This is a question from Doug Crawford, who raised it at the class. To that, the answer is essentially that the FCC regulations are quite sort of strict. And once these projects get underway, then all sorts of issues will come up, which will then have to require international agreement. This this sort of scheme, this project is also um, being handled for regulatory purposes by the ITU, which is the International Communication Union based in Switzerland. So already international bodies are involved, and no doubt there will be regulations that will ensure that abuse does not take place of any sort. Another question that came up was, how long is the life of these satellites? Are they going to just remain as junk up there, going around and round, or are they going to come down and sort of hit on somebody's head? Well, the answer to that is that the design of these satellites is such that their life is 5 years. And after 5 years, they start to lose their altitude. And by which time, once they start to sort of lose their altitude, the motors that are inside will guide them down further so that they burn up in the atmosphere itself. And very few parts will remain which are necessary for laser type of transmissions, because laser works at very high speed. So even if those little parts come down into the atmosphere, they don't burn up. So there is that little element that is there. But that's not to say that, all the satellites are going to sort of cause a rain of debris on our heads. So those are the two questions I remember. There might have been others, but if they do, then I'll take them up the next lecture. My next lecture is going to be on Tesla, I think. Okay, bye-bye for now.